Hello, and thank you for joining us for today's webinar, Project-Based Learning for 3D Printing. My name is Matt DeCecca, and I'm in the marketing department here at Stratasys, and I will be your host for today's event. Before we get into today's topic, I just want to give a brief overview of Stratasys. For those who aren't familiar with our company, Stratasys manufactures 3D printing equipment and materials that create physical objects directly from digital data. Its systems range from affordable desktop 3D printers to large advanced 3D production systems. Additive manufacturing technologies include FDM and PolyJet. Stratasys Direct Manufacturing, a division of Stratasys focused on advanced manufacturing services created by the merger of Solid Concepts, Harvest Technologies, and Red-Eye, helps companies in diverse industries create new products in every phase of the production process, tapping into a wide variety of additive manufacturing technologies. With all this, Stratasys has an unmatched ability to meet our customers' diverse needs through many additive manufacturing technologies. As you can see on this slide, Stratasys has a global reach with 26 offices around the world. We do want to emphasize the point that the curriculum materials that we're talking about today are available worldwide, and we have the offices and resources to support it globally. If you weren't already aware, in late 2014, Stratasys announced its modular semester-long curriculum that introduces college and university students to 3D printing through hands-on projects supported by instruction and discussion. It's the first 3D printing curriculum of its kind, and its intent is to really help prepare students for the future careers, bridging the gap between industry and academia. Instructors can use these materials to supplement existing curriculum or offer a completely new course. A curriculum guide, unit plans, STL files, presentations, and assessments are all part of the materials available. Before releasing this to the public, Stratasys worked with two schools that put the curriculum to the test. The first was Chomyszak Polytechnic in Singapore and Wentworth Institute of Technology in Boston. And we're lucky today to have the professor from Wentworth to tell us about his experience using the curriculum. So I'd like to welcome our presenter today, Steve Chomyszak. Steve received his bachelor's degree in industrial design from Syracuse University and his master's in general engineering from Stanford University. He went on to co-found Mechanology Incorporated, a technology development company specializing in novel positive displacement machinery. He's a skilled machinist and has written custom software for CNC machining and parametric shapes. He also has his own 3D printer in his basement. Steve is now a member of the faculty of Wentworth Institute of Technology, where he teaches courses in mechanical engineering and manufacturing and shares his entrepreneurial experience in the Accelerate program. Steve, I'd like to welcome you and like to have you take it over from here.
Thank you, Matt, and welcome to all of our attendees for today's webinar. We're going to be covering the following topics: ease of use of the curriculum created by Stratasys, the layout of the courses and the curriculum, the flexibility of the curriculum, some student feedback from the class that I taught, faculty impressions from some of the output from that class that the students created, student assessment data, lessons learned and best practices, a brief summary, and we will end with a few minutes of questions and answers. All right, I'd like to give you a brief history here. I'd like to start by providing a brief background of Wentworth's involvement with Stratasys and 3D printing. Since its start over 100 years ago, Wentworth has always been focused on hands-on learning, and in the fall of 2011, it completed a $3 million renovation of its manufacturing center. Included in that renovation was a dedicated 3D printing lab with a Stratasys Objet 24, a Dimension U-Print SE, and a Z-Corp 310 Plus. Basically, we covered the range from powder to PolyJet as far as the printing technologies. However, 3D printing knowledge was limited to a handful of people, and the lab was underutilized for quite some time. Spring ahead to the spring of 2014, I got an email from the director of the manufacturing center asking if there was any interest in working with Stratasys on a 3D printing curriculum, to which I enthusiastically responded. I got to preview the curriculum. I was impressed by its completeness. And during the summer of 2014, Wentworth's administration approved the curriculum for a 4-credit course to be taught as a special topics class. The course was taught to 16 students in the fall of 2014 and was comprised of mechanical engineering, industrial design, biomedical engineering, and electromechanical engineering majors. I will present some assessment data at the end of the presentation to give you an idea of what the students thought about the course. Since then, the 3D Print Lab is no longer underutilized. We've created an online ordering system, assigned a staff member to act as the lab manager, and we hire several work-study students every semester to keep the machines running. The 3D Print Lab is now a very, very, very busy place. Ease of use. The curriculum that Stratasys has put together is very comprehensive. There's everything there from soup to nuts, including a well-laid-out curriculum guide that you can choose to follow step by step. There's sufficient content for 14 weeks of lectures and labs, the equivalent of a 4-credit college course. Some of the units benefit by printing a demo part or assembled ahead of time. The STL files for those parts are included, and there are versions for FDM as well as PolyJet printers. Given that this curriculum is project-based, it only makes sense that project suggestions are included as well. However, you are free to use your own or mix and match as needed to suit your class's needs. The theme of the curriculum is something that moves something, and it really incorporates all of the design and printing tips and tricks presented throughout the course. The theme involves printing a working assembly of pre-assembled parts. You can either have each student design a similar assembly and evaluate them on how well their printed projects work compared to the other students, or you can give them an open-ended project and let them choose what type of assembly they want to build. As we know, students will have more skin in the game if they know that they will be tested on the course contents as the semester progresses. Stratasys also provides a bank of quiz or test questions that you can use. Again, you can create your own if desired. There are also assessment tools that you can use, including a rubric for various assignments and projects. As I stated earlier, Stratasys has produced a very comprehensive curriculum. Layout of the course units. Stratasys has prepared PowerPoint lectures that you can use for each unit of the curriculum. Several of the lectures have links to relevant online videos as well, and in some cases it is up to the instructor to provide content for labs and presentations. We have included a list of the units on the slide. Please note that the unit on gear systems covers 2 weeks, and the printing of the final projects takes 2 weeks for a total of 14 weeks of content. Additionally, there are 6 optional units at your disposal, which include sound printing, which is printing a sound tunnel which can amplify or distort sound from a cell phone, a fluid dynamics unit, which combines 3D printing with an understanding of fluid dynamics, a post-processing unit, which is how you add additional finishes to your parts, a unit on the factory of tomorrow, basically what does the future hold for 3D printing, as well as a field trip. You can either take your students to a traditional manufacturing site or to a digital fabrication lab or a site that has a combination of both. And finally, a unit on regulation and carbon footprint, which covers the legal, ethical, and environmental issues in 3D printing. There is one more point I'd like to make about the curriculum. I was impressed that Stratasys was not afraid to discuss in detail the concepts behind the 3D printers that fall outside of their domain. In other words, the curriculum is about all aspects of 3D printing and is agnostic about which technology is utilized. The curriculum did a great job of objectively presenting each of the technologies, including their strengths and weaknesses. Flexibility. Even though the course is well thought out as is, there is plenty of opportunity to deviate, substitute, or rearrange the units as needed. I would, however, recommend that the first 4 units be taught in order. They are vital in providing an understanding of the fundamentals and terminology used in 3D printing. After that, you can mix and match to your heart's content. Student feedback. At the end of the semester, each of the 16 students in the course filled out a survey. One of the questions was, what did you like the most about the course? The answers are self-explanatory. In this case, I allowed the final project to be open-ended, which provided each student with the opportunity to design and print something of particular interest to them. As a general rule, the students enjoyed that. It gave them a chance to apply some rigor to something of their own creation. It was, however, not without some challenges. The next question asked was, what did you like the least about the course? There were a few students who were uncomfortable with the open-endedness of the final project. Also, the students at Wentworth are normally required to pay for their 3D prints. As in real life, taking cost into account forces there to be a certain level of efficiency and responsibility. However, in this course, we waive the cost for the students, but as an exercise, we tracked how much their prints would have cost. In some circumstances, the student prints would have been several hundreds of dollars. In those cases, I would give the students some pointers on how to reduce the cost and send them back to revise their designs. These were lessons well learned. The third comment here on this list points to the fact that it is hard to teach students how to use software when it is locked to a single computer in the 3D print lab. I would like to propose to Stratasys that a possible solution would be to make their software available for download to anyone who wants to learn it. This would be excellent for an academic environment, but I understand that it may cause concerns in the commercial markets. However, academia typically has access to lots of commercial software under educational licensing arrangements, so I am hopeful that Stratasys could follow suit. After all, the very curriculum that we are discussing today is available to anyone at any time for download. The fifth comment pertains to the consumables used in the 3D printing process. In the case of FDM, the build tray is not reusable and must be discarded. The support material is discarded. The reels used to spool the ABS filament are discarded, and the detergent used to dissolve the support material is discarded. Each one of these consumables add to the cost of the print, which our students must pay for. Some of the items could be recycled if they had the universal recycling triangle molded onto them, but as it stands now, we are unable to recycle them at our campus, and they end up in the waste stream. The final comment is indicative of two things. The curriculum inspired the students to think big. Despite lots of pleading and prodding from me regarding planning and scheduling, sometimes they bit off more than they could chew. One of them regurgitated back to me a comment that I was once told while in industry, and one that I make sure to mention in most of my classes, which is, don't let great get in the way of good enough. There is not time in one semester to design perfect things unless they are simple. On the other hand, learning is maximized when you are challenged, so there's a balancing act that must be undertaken by the instructor to maximize learning and minimize student frustration. This question really puts the course to the test. Would you recommend this course to a fellow classmate? And it was unanimous. All 16 students would enthusiastically recommend the course to their classmates, regardless of what major they were in. This is a testament to the importance of 3D printing as a whole and to the quality of the curriculum developed by Stratasys. Faculty impression. As most of you may know, we all have our areas of interest, course schedules to manage, student advising, institutional service, papers to publish, etc. And sometimes we get caught up on our own challenges and don't always take notice of other things going on around us. In this case, the faculty at Wentworth, who have become accustomed to seeing static prints emerge from the 3D print lab, all of a sudden had lots of questions and observations regarding the something that moves something prints. We now have working assemblies coming to life in the 3D print lab, and that caught their attention. I am now working with one of our faculty to incorporate 3D printing into the curriculum for his course in kinematics. He has been a proponent for some time of the matroid method for predicting kinematic outputs from various types of linkages. This method is directly applicable to future 3D printing courses based on what Stratasys calls dynamic surfaces, another exciting use of 3D printing to print intricate assemblies that, via kinematics, allows the resulting prints to morph into alternate shapes. We are now working together to develop an app that incorporates the matroid method so the success of the printed dynamic surfaces can be predicted prior to the actual printing. I have also worked with professors in manufacturing, industrial design, architecture, humanities, mathematics, and biomedical engineering to incorporate some form of 3D printing projects into their courses. The list continues to grow, and Wentworth will soon need to start buying more 3D printers and expand the capabilities of its 3D printing lab. The Stratasys curriculum contributed to this success. Assessment data. Our end of the semester survey contained 7 statements based on the course objectives, which were published on the Stratasys website. And I asked each of the students to rank their level of agreement or disagreement with each statement on a scale of 1 to 10, with 1 representing strongly disagree and 10 representing strongly agree. There were 16 students in the class. All right, here are the results from objectives number 1 and 2. Objective 1. The course provided you with knowledge of key historical factors that have shaped manufacturing over the centuries. And you can see in this slide that most of the responses lie in the upper third. Objective number 2. The course explained current and emerging 3D printing applications in a variety of industries. And in this case, all of the responses lie in the upper third of the range. Objective 3. The course provided a description of the advantages and limitations of the main 3D printing technologies. All of the responses lie in the upper third, which is a testament to my earlier statements about the curriculum being technology agnostic. Objective 4. The course provided you with the ability to evaluate real-life scenarios and recommend the appropriate use of 3D printing technology. And again, the large majority of responses lie in the upper third of the range. Objective 5. The course provided you with the background to be able to identify opportunities to which 3D printing technology can be applied in order to reduce the time and cost of prototyping or small lot manufacturing. Again, this slide has a similar response as those of the previous slides. Objective 6, the course provided you with an understanding of the economic implications of 3D printing, including its impact on startup businesses and supply chains. Here, there was more of a spread of this data. I think in this case, this is because the students were much more interested in their projects than thinking about economic implications, even though the economic implications are significant and are largely what have driven the success of 3D printing. And lastly, Objective 7. The course provided you with the information necessary to design and print objects containing moving parts without assembly. We can see here that the students learned, or at least came to appreciate, the tricks and tips needed to print successful assemblies. Important lessons learned. First one, in order for one part to move with respect to another, there needs to be clearances between the two parts. When printing such an assembly, the clearance between the parts needs to be filled with the support material in order to prevent the parts from fusing together. The minimum amount of clearance needs to be sufficient to allow the printing of the support material in the interstitial space between the parts. The minimum clearance is a function of the printer's resolution and capability, so you have to make sure you have sufficient clearance between those parts. Item number 2. In order for the part of the assembly to function properly, the support material needs to be removed. This means that the design needs to take into consideration, either by providing generous areas to maneuver in, to manually remove support material, or to provide windows in the parts through which the support material can be removed. In several cases, removal of the support material was the most frustrating obstacle that the students experienced because they did not fully appreciate its importance until it was too late. Number 3, occasionally you will encounter a corrupt STL file. STL files and OBJ files are the language of the 3D printers. This always happens when one surface pierces another surface and is an artifact of modeling techniques. So you have to be sure that the students are skilled in their 3D modeling. It can also happen if the surfaces representing the outer boundaries of the parts are not watertight, and this means that the surfaces are non-manifold. Sometimes the surface normals, which are used to determine the inside of the part from the outside of the part, become inverted, and this is a common occurrence. There are free programs such as NetFab or MeshMixer, which you can download from the internet. They can often correct these situations, but success is not necessarily guaranteed. Another recommendation that I would make to Stratasys is to add a print simulator to their software so that print errors can be discovered prior to printing, much the same as is used in the CNC machining industry. This is because sometimes a print takes several hours to do, and despite some errors in the print file, it might actually print successfully but come out to be the wrong part. So having a print simulator that actually simulates the real live printer instructions prior to printing would be a very useful tool. Item number 4. This is a common thing when designing on a computer screen. We lose our sense of scale. So to combat that, have the students keep a ruler or a scale handy while doing their modeling so they can get a feel for the true size of their parts as opposed to believing the zoomed-in view on their computer screen. In several occasions, what looked great on the screen turned out to be parts that were less than a millimeter in diameter, and consequently were very fragile and broke. And lastly, encourage creativity and experimentation. but help the students set realistic goals for their final projects. And the summary. Stratasys has certainly created an effective and engaging 3D printing curriculum. It is turnkey and includes lesson plans, presentations, quizzes, project suggestions, and assessment tools. It is project-based, which provides a hands-on design through to print experience where the students learn by doing. And it is technology agnostic and covers all major 3D printing technologies. 14 weeks seems like a long time, but it isn't when it involves student design efforts. Encourage 3D print experimentation. It's okay not to get it right the first try. Making mistakes is part of learning, but be sure to set realistic goals. I strongly recommend that the students as well as the instructor be proficient with a 3D modeling program. Otherwise, there will be frustration for those students who don't have a basic understanding of how to model parts using 3D CAD software. And this brings me to the end of my presentation, and I will now turn it back over to Matt.
Thank you very much, Steve. That was excellent. Just want to let the audience know that in a minute we're going to take questions that have come from everyone on the webinar. If anyone does have any questions in the meantime, please feel free to submit it through our Q&A or chat panels. After today's event, you will have access to download a copy of the slides and the webinar recording, and that'll be at stratasys.com/webinar-curriculum. There will also be a chance to get a download link where you can download the curriculum guide and gain access to any curriculum materials that we do have. So with that said, I will now go into some Q&A. And it looks like we do have a couple questions coming in so far. So please, as I mentioned, keep these questions coming. We do have some time left. So Steve, I'm going to start with an attendee. Her name is Jessica. She's wondering, based on the time and money that goes into the 3D printing process, how does that compare to the traditional ways of making things?
Oh, that's a great question. Well, our students were sensitive to the cost issues just because we tracked them in the course. But what we did make a point to say is that in industry, time is money. And the 3D printing process reduces the amount of time it takes to develop a final product. And if you can save that time and beat your competition to market, well, it's well worth and justifies the cost of the 3D prints. Next question?
Absolutely. Let's see here. So we have a question from Jason. He's asking, how do you structure your lab? In other words, do you allow other departments to use your 3D printers, or do you charge them?
So the 3D printing lab located in our manufacturing center is available to everybody at Wentworth, students, faculty, and staff. And we do charge for every print made. As I stated earlier, the economic parameter induces a certain efficiency and helps to cut wasted time and resources due to the lack of effort in the design stage. But basically, we make the lab accessible to anybody on campus who wants to use it. And in fact, we've had to help facilitate that as demand has increased by having an online ordering system. A lab manager now who manages the queues of prints, who helps the work-study students be sure that we have things done on time, who orders all the materials and maintenance for the printers. So it's turning into quite a campus-wide service bureau.
Excellent, excellent. Now, Michael has a follow-up question here, and he's asking if you can elaborate just a little bit more on how other departments would use your 3D printing capabilities.
Well, due to the success of this course and having the students' prints making out to the public view on campus, we do get a lot of inquiry from other departments on how they can incorporate 3D printing into their curriculum. In fact, other departments are now considering buying their own 3D printers. They're kind of outgrowing our ability to service all of their students. We have about 4,500 students on campus here, and 3D printing is becoming just as common as reading a textbook. So many departments are planning purchasing their own printers, and certainly we will help facilitate that with them and help them get up to speed with their own printers.
That's excellent. Seems to be spreading quickly across Wentworth.
Spreading quickly. As I said, 3D printing is a very, very, very busy place right now.
Excellent. We'll move on to the next question here, and this comes from Betty. Do you partner with industry at all and make parts for them or work with them in any way?
We do not partner with industry. Industry moves at a faster time scale than academia does. And basically, our 3D print lab here, its priority is to service our immediate academic community. However, that's not to say that we don't take on special projects from the outside world. Wentworth is located very close to some of Massachusetts' premier medical centers, and we do occasionally print parts to aid the surgeons in planning of certain medical procedures. And in fact, we can go from MRI to 3D printed part right here at Wentworth.
Excellent, excellent. Let's see, another question here is going to be from Juan, and he's asking, are you planning on teaching this course again next year, and what are your future plans?
We do. Due to the success of the course and the exposure from the 3D printing, there are definitely plans to teach the course again. In fact, I just got done speaking with my department chair, and I will be proposing to Wentworth to make the course an official elective as opposed to a special topics course available to all the students and the faculty and staff on campus, and to make it part of our regular offerings, as well as to make an integral part of our manufacturing minor for our engineering students.
That's amazing. Thank you, Steve. Well, it looks like our time here is just about up. If we didn't get to any of your questions on the call, we'll be sure to follow up via email. I want to thank Steve again for your time and insight on this topic, and thank you for everyone else's attention during the presentation. So for now, I will turn it over to our operator who will close out the event. Thank you, everyone, and have a great day.